In this chapter, we are going to cover Einstein Discovery. Einstein Discovery comes with Tableau CRM platform or the product, especially if you have the TCRM Plus license or the Einstein Predictions licenses or any license related to the product that provides the Einstein Discovery feature. And we are going to cover a few basic terms and basic introductions. So we're going to go over the introduction to Einstein Discovery, ED, the role or the skill sets needed for a business scientist. This is aka also known as citizen data scientist. This is the new persona for which this tool would be pretty much their tool of choice. And how to approach a use case. So we've had a lot, and we will be covering the technical aspect of the product, how to use it, but we also want to cover how to approach a business use case or a use case, how to build that up and know how to apply the product for that use case. The importance of the business knowledge. This is going to be very important, again, relating back to the business scientist persona. The good and the not so good fit for ED. Some important terms, as I mentioned, and the typical analytics assets related to Einstein Discovery. A quick exercise as an introduction and talk about limits, what you can do with the product from volume, from predictions, etc. All right. What is Tableau CRM Einstein Discovery? What are Einstein Discovery, pretty much the predictions that get deployed from that? I would like to start say that it's in the same way Tableau is data for everyone. TCRM is actionable predictions for everyone, or specific Einstein Discovery is actionable predictions for everyone. That is what we're trying to do. Democratize AI and predictions for the end users and spread the SME knowledge to the end users too. And I'll cover that in a bit in more details. So the product is a leader in augmented analytics, AI built in. It's part of the platform. You'll see it in a bit. Prediction scores, but also explanations in natural language and actions, recommendations, recommended actions, what you can do to increase or decrease or maximize, minimize that particular variable that you're trying to predict through these predictions. It is native to Salesforce, meaning the platform itself, the data, the place where the model sits, everything is in Salesforce. So, and it is native again to the Salesforce environment. It's API ready. You can take the predictions deployed and score any data outside, as long as you can, connect to the API or send the information to the API. It is app centric. We build it around a business use case, and again, we will cover this in details. And the value is pretty much this: driving the efficiency of the end users, augmenting the daily business flow that I deal with as an end user with intelligent insights that allow me to do my job much more efficiently and again contribute to that particular variable that we're trying to maximize or minimize. So Einstein, the word Einstein by itself, there are many products across Salesforce that again utilize or use the word Einstein. So I want to clarify a little bit where Einstein Discovery sits. If you think about the spectrum of Einstein or AI products we have, you can think about these as three main buckets. To the left are out-of-the-box AI features. You have a license for them, you pay for it, and it automatically shows. Let's say if it's a predictive field, it shows automatically on the object, and you use it. You don't control how it's built. There probably are requirements to have X, Y, Z of these particular fields and these particular objects to have that feature works. So pretty much these are out of the box, not a lot of control. We move to the middle bucket. This is where it's supervised AI with a tool that helps you build the model, create the stories, and deploy models as predictions. So you have a say in how the model is built. You can see the explanations. You can bring in data from outside Salesforce. You can combine data. You can use the predictions outside. So there's a lot of features here, and this is pretty much where we're targeting that persona of the supervised AI or with Einstein Discovery. And of course, there's the third bucket where it's pretty much the deep learning, data scientist heavy, and this is where we just provide. I mean, put in a simple way, we provide the platform to build that particular ML model, whatever you need to do. And again, it's more targeted to the heavy data scientist persona. So with that, Einstein Discovery, again, it is integrated in Tableau CRM. So I know we call it different names, but it's pretty much, it is within the stack. You get the data to a data set through the data platform. You can prep it through data prep. You combine it, add the right fields, etc. And then you build a story or a model. We use those two words simultaneously. It's pretty much where you are, again, doing your AI work, building that model, and then you deploy it as a prediction, and that prediction can be consumed somewhere else or outside, or you can rescore back into the data layer. But pretty much what I'm trying to cover in this particular slide is that it is part of the platform. It is a layer, intelligent layer in the platform in Tableau CRM. And all of this is within Salesforce. And again, as a reminder, you can bring data that is natively from Salesforce or from outside. And this is the beauty here, that you can actually build models based on both, combined data. And you can then deploy, again, back to Salesforce objects, or you can just deploy outside as an API service, or even to Tableau, whatever you want to do, again, depending on the use case, what you're trying to do with the product. And this is the ultimate end user experience. Specifically in this particular case, is the Salesforce user. And what we're trying to do, again, with all of this augmented analytics, is provide that rich daily experience for an end user who's logging into their Salesforce environment, looking at their accounts. They're dealing with their transactional data on a daily basis. This is what I do on a daily basis. Maybe adjust the field, create an activity or a task, etc. But also I have my typical analytics, and this is my trends, my historical analytical insights. This is your typical reporting or dashboards, or typical analytics that embedded in the account page. But also on the right side, I have the predictions, and this is the new, right? I have a prediction score. I have causes, so it's not just a black box number that I don't know why this number is 77. I actually see some of the leading causes. I even can see the how to improve it. So this is very important. This is where I can take an action immediately without even going back and emailing someone or waiting on a resolution or etc. I am again spreading that's the thing I mentioned. I'm spreading the SME knowledge, knowing what to do in a certain situation to the end user through these recommendations. I don't want to use the word recommendation, through these improvements for this particular or these actions for this particular score or this particular field. And again, this is the augmented analytics. This is how we want to drive predictions. Like I mentioned, it's predictions, actionable predictions for everyone. And it's very important, as we're going to mention on this probably multiple times, that it's not just getting the model that gives me the right number and the right action, but also operationalizing AI. And this is very important, because as you're going to see in this particular video here, that we're going to cover the terms, and we're going to do an exercise how to build this, or at least get the predictive field. But how do you operationalize this? How do you bring everything that you build fast and in a fast way to the end users? That's what we're trying to do, and we're going to show you in the other chapters or videos when you deploy predictions. So Einstein Discovery is, again, I mentioned this is a powerful augmented analytics tools. It focuses on 4 questions that have become a staple in analytics, which are the descriptive, diagnostic, predictive, and prescriptive analytics. And essentially what they mean is what happened. I'm looking at the data, what happened. This is historical. This is typically where we would use reports and dashboards. Why it happened. We could solve this historically with some dashboards. Granted that we had the right chart and the right KPIs and metrics and dimensions, looking at them at the same time, and then we could deduce something, why a trend is going down or up. But now with AI, this has become automated, and I'm looking at all of the possibilities of my dimensions and measures interacting, and I'm looking at it statistically in a way that it's being statistically proven, not just like a business hunch or an estimate of why it could have happened based on my experience. And then more importantly, the what will happen and what to do about it. And these are very important, meaning that now that I know why it happened and what can happen in the future, what should I do about it? So these are what we talk about: unbiased explanations, predictions, and recommendations. Unbiased in the sense is I'm not coming here with my 2 years or 4 years or 10 years of experience, which might be true, which might be, I might be saying the same thing as what ED is going to say, but that's a validation for ED because it is validating that it's equal to the same experience that I've had, but also through math and through statistics. So a few things also too important that the insights, the predictions, the prescriptions are very important in the sense of we're providing a prediction with explanation. This is very important in business use cases, and you're going to see that we are focusing on solving typical business use cases. We're not going out and trying to solve, for example, climate change and predicting big complex problems out there. This is important because we want to keep the ability to explain the insights. You will see this also as we go through the rest of the chapters here or videos. It is rapid in the sense of I can load data, run a story, check the model. The model metrics are not good. Go back, change something in the data, run it again fast, or change the inputs, or add some derived fields. Again, that iterative process or the ability to just load the data, of course, after I've prepped it and changed it, and run the story of the model multiple times is a very fast thing, and it helps me get faster time to results or faster value of my product without sacrificing the quality of what I am trying to create here. And it is supervised or augmented in the sense that we control, as the business scientists or the experts using this tool, we control what's going on. What are the input variables? You're going to hear me saying input and output, right, or explanatory. So output is what we're trying to minimize or maximize. Input are the fields we are including in this data set. We're including in this story. We're saying, go back and study the relation between these fields and their values if they are affecting the output variable in a certain way. And it is important, and I'm going to focus on this multiple times here, the business understanding of or the business knowledge of what we're trying to do. So if it's a customer churn, if it's sales opportunities, if it's lead conversion, if it's service, CSAT, etc., you need to understand what the business cares about, what makes sense from a business perspective, and this will influence the data to be used, the scope of the data to be used, and even insights that you're seeing, and validating, for example, recommendations in the engine. Maybe it says, because you're going to see Einstein Discovery has data improvements, it's going to say, these fields are duplicates. They provide the same information. So maybe that's something you want to verify with the business before just going with a biased opinion, if it's not super clear if they are duplicates or not, etc. And what can we do with Einstein Discovery? We can create, again, supervised models that are used to predict or to be deployed as predictions. I'll go over how these terms or assets fit together on a different slide. But mainly what we can do with the product right now is binary classification and numeric use case. So binary classification use case or numeric use case, meaning we can tell you, you can use this tool to minimize, maximize a number that can go, from, it's an amount of opportunity. Could be anything. That's a linear. That's a numeric. So units sold, days to close, revenue, customer satisfaction. That's a number. And Einstein Discovery automatically, once you select that this is the field I'm trying to predict, to maximize or minimize, it detects what type it is, and it applies the correct, for example, linear regression in this case. If it's a binary, if it's a did I win or not this opportunity, true or false, 1 or 0, churn or not churn, it will detect it's a binary and do a logistic regression. Now, under the hood, there are different algorithms. We're going to cover that later on, but this is at a high level what kind of regression is going to be used. So, and I'm covering this so to clarify, like for example, we don't do multiple clustering. We don't do classification more than 2. In this particular use case, for example, that's another one. And to just visualize it really quick, typically you want to predict a number. In this case, it goes maybe from 0 to whatever value it is. So that's how a linear might look like. And again, we're trying, based on the data that we have, the historical data, these are all data we know. Now we're trying to predict. So in the future, if any new value comes around here, we're going to say, okay, well, our prediction is going to be this value. Okay. And if it's binary classification, again, we're trying to split. If a data comes in, or if whatever that data comes in, and maybe it's here, well, it's okay. It's a circle. If it comes here, then we're going to say it's an X, etc. And here's some more examples on the cases or the Einstein Discovery, what it works on. Numeric outcomes, like we mentioned. Translated to business questions: how much revenue can I expect? How long will this deal take to close? How much will this house sell for? For a true-false outcomes, is this customer going to churn? Is this lead going to convert? Will the student graduate on time? Etc., etc. Now, why I'm covering this again one more time, because there's going to be an important role for that business scientist. And again, this is a persona. Think about it. It could be the analyst or the data, if they know the business, well, or a combination of all these 3 people, 2 people, even the data scientist, if it is on the team. Sorry, if it is, if it is a requirement, or if that team exists and they are engaged in the beginning or at the end to validate the models, etc. All of these together, I'm just going to call them business scientists, and the business scientist's job is going to be crucial to take the business problem, which could be like we're losing money, or we're not moving fast enough, or we're losing customers, or there's some efficiency that can be done. Take those statements, translate them to what metric that can be minimized or maximized to provide that value, that benefit value from the product. Okay. And here's some more common use cases. So you can look at the under the different industries or under the different clouds, whether sales or pharma or wealth, financials or wealth, retail or other. All of these are valid use cases that we have customers that have covered using Einstein Discovery. So you heard me mentioning about the business scientist, and this is going to be important. The business scientist is a persona that understands the business. So 33% business expertise. They have to, because, and I will cover that a little bit more detail, but pretty much because they need to relate what the tool can do for the business. 33% data and analytics expertise, so they kind of understand some data concepts. They might have dealt with some reports and dashboards before, etc. Or they have come up with the KPIs and metrics that the business cares about. And the last circle, the red, which typically these personas or these teams lack, is the statistical terms knowledge or some predictive tool familiarity. So what I mean by this is you're going to see in Einstein Discovery, there are the easy parts where you look at the chart, you look at the explanations, etc. But there's also the not so easy parts where you're looking at the model performance, model accuracy, model metrics, R square or MSE, or even confusion matrix and the threshold. Those things need a little bit of a statistical information or knowledge. You don't have to be an expert, but it is good, and it is kind of assume that you will be able at least to glance at them and know what they mean, or know what if the values are high or low, or something needs to be changed or not. Also, if you typically have a data scientist team who will be validating or providing the last approval on the model accuracy to be deployed, you want to be able to talk the same language and kind of relate. So again, you don't have to be a data scientist, but you need to know these statistical terms a little bit. And again, as a reminder, that we are focusing on the business use cases, and we are providing this in the UI. You don't have to write Python or R from scratch. And even the need for developers and integration and deployment or operationalizing the final product, which is the prediction, everything is taken care for within the product itself. All right, we're going to cover the technical terms and again how to use the product. But how do I approach my business problem and categorize it in a way that I can use Einstein Discovery to help me, solve that problem? So there's going to be 6 questions, typically 5 or 6 questions, and you want to follow this template. Now, again, there's multiple ways. There's different ways out there, or you might find that you might add 1 or 2 steps, but this is pretty much the core of it. So first, you want to start with what is the problem you're trying to solve. What is it exactly the problem you're trying to solve? Because you're going to walk into a meeting, or you're going to go, if you're on the customer side, still your own customers are the business. And you're going to hear a lot of different business use cases, a lot of metrics, a lot of asks or demands. So you're going to have to walk through that, kind of prioritize them, or get an agreement on what use case you're going to start solving, and go on defining that. Then you're going to create the variable that tracks the performance or tracks the metric that affects that problem. And again, we're going to cover customer churn. So if you think it's customer churn, then it's the churn flag. Like I need the churn flag. Did the customer churn or not, for example? So again, you have to create the variable because that is what Einstein Discovery does. It maximizes or minimizes a variable. Are there any glaring problems? So, for example, when you create the variable, is there any problem with that variable? Do you need to maybe create a new variable? For example, if we're talking about promotions, I want to see if certain promotion is working as expected. Well, when do I measure? Do I measure the day I deploy or put that promotion on the shelf, or after 3 days or after a week? Customer churn. Do I look at all, for a customer to churn, if there's a flag for that customer, 1 or 0, well, a customer can be 10 years and a customer can be 1 year, and eventually all customers churn. So how do you find that flag, that variable you just agreed on? How do you know it is, it works for your business use case? Because again, all customers churn. So if you say I'm going to just use the flag by itself, that's a problem. There's a problem with that variable. You're not tying it to a time, a window, so that so your definition is a customer that churns within a year or 2 years, right? So again, that's kind of, could be the problem with the variable. You just thought it's very simple and just a flag. The level of insight. So this is very important because we're going to create data sets, and that data set has to have a grain. That is the one record per customer. If it's customer churn, for example, that would be one record per customer. If it's opportunity, it's one record per opportunity. So you want to make sure your data set has a unique record per op. So, when you build the story and model, there's no confusion. It is one record, one occurrence, one observation of that particular opportunity or customer. Decide the appropriate scope of the data. How many years you want to go back and look at the data? Do you want to look at your last 5 years of data or 2 years? Did the business change? Maybe your business model changed, or the service you just deployed only 2 years ago for these particular customers versus your business has been running out for 10 years. So you want to know what's the scope of the data you're going to bring into that data set. And what the variables you are including in the model, the variables that you're including in that story or model, do they make sense? Are they historical? Meaning, if you have a variable that is input or it's being populated after the event happens, that might not be helpful for the model. For example, if you take an opportunity and you are trying to predict if this opportunity is going to close won or close lost, and you're including multiple fields, from the opportunity object. Well, one of the fields might be opportunity lost reason. So if you include this in the model, in the story, then Einstein Discovery is going to predict 100% saying, I know this opportunity, if it's going to be won or lost, if the lost reason is populated. Well, that doesn't help me. That this lost reason is always populated after the opportunity closes, after the prediction should have happened or might or would have happened in the future. So again, these kind of fields, you don't want to include them in your story or in the data set.